All right, POE students, hopefully you've been looking at the material and you're ready to work on activity 411, data exploration. Again, the understanding and manipulation of data allows decision making to be based on the outcome and even predictions. So what are we going to need? We're going to need a coin or a digital coin, dice or digital dice, and a calculator. So let's go through this. What is the probability that the illustrated board game spinner will land on blue? Well, what's the experiment? Well, spin the arrow record caller. Define the sample space. The 6 unique callers. You could list them here. Define the event. Well, the event that we care about is spinner landing on blue. What's the probability? Well, how many chances are there to land on the blue one? 1. All right, how many different opportunities are there? So there's 1, 2, 3, 4, 5, 6. So probability would be 1 out of 6. Okay, and if you convert that, that'd be 0.167. What's the probability of a flipped coin landing on heads? Well, heads and tails. So you have 1 out of 2, which would be 0.50. All right, what's the probability of a flipped coin landing on head 4 times out of 6 trials? Well, if you remember that fancy equation that we did earlier, P equals n factorial P to the x Q to the x minus n all over x factorial n minus x factorial. Okay, this is something you can just have in your cheat sheets. All right, so let's define what all this means. Okay, well, n is the number of possibilities, so 6. P is the probability it'll happen. Well, it's a coin toss, so it's 0.5. Q is the probability it won't happen, so that's 0.5. X, all right, is the number of times we want it to happen. So there's our X value. Okay. We know Q and P, and N was how many trials. So now it's just plug and chug. So probability equals n factorial, so 6 factorial, 0.5 to the x, which would be to the 4th power, 0.5 to the, it should be n minus x here, sorry, n minus x, which would be 2, all over x factorial, and then n minus x factorial, so that'd be 6 minus 4, so that'd be 2 factorial. Okay, so we're going to plug and chug that in our calculator. Well, if you guys remember anything about Algebra 2, I can cancel 4 factorial and basically the 4 factorial up there. So it's really going to be 6 times 5, still times 0.5 to the 4th, times 0.5 squared, all over 2. Well, we can slash and burn that 2 and that 6 and make that a 3. So now it's going to be 15, because that's 3 times 5, times 0.5, okay, to the 4th power, to the squared. So, if we remember right, that's to the 16th, or the 6th power. So when we do that math, and again, I'm sorry we don't have my handy dandy calculator on this one, But when we do the math, 15 times 0.5 to the 6th power, we're going to get 0.234,375, or 23.4%. Okay. All right, number 4. Calculate the probability of a flip coin landing on heads through experimentation. So it says flip a coin 10 times, record your data below. All right, so what I'm going to do is I'm going to go to this coin flipper tool. And I'm going to put in, I need to flip it 10 times. I'm going to pick the $50 coin because it's the most expensive coin they have. So I'm going to hit flip. Okay, tails, 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 tails. So it looks like 6 tails and 4 heads. Okay, no big deal. I'm just going to go 4 heads and 6 tails. Okay, if you have a coin, you can go through and tally it all up. I'm okay with you doing the data that way. Calculate the relative frequency. The relative frequency, if you remember, is what really happened. So, of landing on heads. So I flipped heads 4 times. How many trials did I have? I had 10. So 0.40 or 40%. Well, we know it should be really close to 50%. Okay, now it says toss a fair coin 50 times. Okay, I'm going to go back to the other one I just had here. I'm going to go back, and now I'm going to hit 50. Oop. So I'm at random.org.coins. So I gave you that link earlier. So now I'm going to flip the coins. Okay, so let's count the heads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, so I have 26. So we'll scroll all the way down here. So I had 26 heads. So that must mean I had 24 tails. Calculate the relative frequency. Again, 26 over 50, because it still said heads, right? Yeah. So do the math. That's going to be 0.52, which is 52%. Now your numbers are obviously going to be different. And then E. Okay. What I'm going to need you guys to do is post in the 4.1.1 homework forum. And then you can add them all up and then do relative frequency. Describe the relationship between the relative frequency of the coin landing on heads and the probability of a single coin landing on heads. Does the sample size affect this relationship? Remember, as we approach infinity, we approach theoretical probability. So you guys can fill that out in your own words. All right, so number 5, create a histogram representing the summation possibilities of rolling 2 dice. Okay, so rolling a 2 and a 3 is not the same as a 3 and a 2. So what's the smallest number I can get rolling 2 dice? A 1 and a 1, right? So I can get a 2. Then I could roll a 3, I could roll a 4, I could roll a 5, I could roll a 6, 7, 8, 9, 10, 11, 12. Okay, I'm also going to add this. This is the histogram, so I'm going to make that a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, how can I roll a 2? Well, I can roll a 1 and a 1. That's it. Okay. Can I roll it any other way? Think about it for a second. That is it. How can I roll a 3? I could roll a 1 and a 2. I could roll a 2 and a 1. 2. How can I roll a 4? I could roll a 1 and a 3, a 2 and a 2, and a 3 and a 1. So that's a 3. What about a 5? I could roll a 1 and a 4, 2 and a 3, a 3 and a 2, a 4 and a 1. So 1, 2, 3, 4. What about a 6? I could roll a 1 and a 5, a 2 and a 4, a 3 and a 3, a 4 and a 2, 5 and a 1. 1, 2, 3, 4, 5. Hopefully you see the pattern here. What about a 7? 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, and a 6 and a 1. 6. So what do you think is going to look like next? Well, 8. I can't roll 1 in anything to get 8, so it would be a 2 and a 6, a 3 and a 5, a 4 and a 4, a 5 and a 3, and a 6 and a 2. That would be 5 as well. So what about 9? I could roll 3 and a 6, 4 and a 5, 5 and a 4. Alright, what else could I roll? Can I roll a 6 and a 3? Sure can, so that's 4. How about a 10? Could run a 4 and a 6, a 5 and a 5, and a 6 and a 4. That's 3. 11 would be a 5 and a 6, or a 6 and a 5. That's 2. A 12 is a 6 and a 6, 1. So I can plot my histogram like this. Rolled a 1, a 2, a 3, a 4, a 5, a 6, 5, 4, 3, 2, 1. So you could fill it in now. And you can get all fancy with the colors. But that's your histogram. Alright. And you can get fancy with the colors. Hopefully that makes sense. It's pretty self-explanatory. Okay, what's the probability of rolling a 7? Well, let's look at our histogram. Okay, there's 6 of them, right? Let's count the boxes. 1, 2, 3, 4, 5, 6. Or you could look at this data. 6. So we need to know what's the sum right here. So let's add them up. 1 plus 2 is 3. Okay. Plus another 3, 6. Plus a 4 is 10. Plus the 5 is 15. Plus the 6 is 21. Plus the 5 is 26. Plus the 4 is 30. Plus the 3 is 33. Plus the 2 is 35. Plus the 1 is 36. So it's out of 36. So what's the probability of rolling a 7? 6 out of 36, which would be 1 out of 6. Alright. Which is going to be 0.1667. What's the probability of rolling a 12? Well, look in our frequency histogram. There's only one chance to roll a 12 out of 36. So do the math. That's going to be 0.0278. What's the probability of not rolling a 9? Well, how many chances are there to roll a 9? 1, 2, 3, 4. So there's 36 chances to roll something. But not to be a 9, you'd subtract 4 over 36. So that would be 32 over 36. So you can do handy dandy calculations. That reduces to 8 over 9, which goes to 0. If you remember the deal, 8888. All right, easy stuff. Box our answers. All right. Simultaneously roll 2 dice 50 times and record your data. Okay, that's a lot of stuff. So I'm going to go to a different website here that's called Roll Dice Online, roll-dice-online.com. Number of sides, I want to roll a 6-sided die. Number of dice to roll is 2. And it said roll it 50 times. And it gave you a cool little chart to record everything. Okay. Now the bad thing is, this thing doesn't give us a way to simulate it. To collect the data. All right. So there's all my data points. I can go back through and fill them all out. Okay. And we're going to treat each dice separately. Okay. So I'm going to pause for a second and collect all the data. All right, we're back. So what you'll notice is over here to the right, to the left, I used an Excel spreadsheet and kind of hurried that up. So we know it's 50 tosses. So number A says, what is the relative frequency of rolling a summation of 7? Well, if we look over here, we can just count our 7s. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and that's out of 50. So the relative frequency of rolling a 7 is 8 out of 50. Okay, 0.16. Okay, what's the relative frequency of rolling a 12, a sum of 12? Okay, so let's look at a sum of 12. I did it 3 times. So 3 out of 50 should be 0.06. What's the relative frequency of rolling a 6 on a single die? Well, remember, we rolled 50 times with 2 dice, so that's actually 100 possibilities. So let's pull that up. And the easiest way to do this is, we could do a function, but we're just going to quickly sort from largest to smallest and count them in this row. 1, 2, let's see, what's that count right there? 13. Okay. Okay, 13 of those. And then in this one, same thing. 15. So I have 13 plus 15, which would be 28 out of 100. Okay, which would be 0.28. All right, what is the relative frequency of rolling a summation of 6? So let's go back to my data. Let's resort by sum. If I can get the mouse over here. Okay, sum. I'm going to do smallest to largest, so summation of 6. 1, 2, 3, 4, 5, 6, 7, 8. I can't move it. So it's 8. Again, that's out of 50 opportunities. Were your dice loaded? Well, what you're going to have to do there is go through and look. So what's the probability? Think about this. What's the probability that you rolled one? Okay, so think about that. So the probability of rolling one dice is 0.6166. So the probability of rolling one die is 0.16. So if you look, the relative frequency should be around that. Well, what do you notice about the 6? We rolled that 0.28. That's a lot more. So we could say the 1 dice may be loaded on the 6, but you're going to have to go through and do your evaluations and see if there's any that are really, really skewed. All right. Again, so you're going to have to do a little bit of work on that one. So number 10 says, 1 coin is flipped 4 times. What's the probability of flipping 2 heads and 2 tails? Okay. Flipping 2 heads and 2 tails. So let's write the equation. Probability equals n explanation point p to the x q to the n minus x all over x factorial n minus x factorial. Okay. So let's define everything. What's our n? How many trials do we have? We have 4. Okay, what is our x? Okay, our x is going to be 2. Okay, what's our p? 0.5. What's our q? 0.5. Alright, so now it's just plug and chug. So I'm going to have 4 factorial times 0.5 to the x, which is 2, times 0.5 n minus x, which is going to be 4 minus 2, all over x factorial kn minus x factorial, which would be what? N minus x would be 4 minus 2 factorial. Okay, so do the math. Remember I told you 4 factorial, so that's going to be 4 times 3 now. 4 minus 2 is just 2 times 1. So I can slash and burn a little bit more and get rid of that 2 and that 4, make that a 2 and that a 1. So now I have a 2 and a 3, so that's 6 and 0.5, 2 and 2 to the 4th power. So I can do that math, and I'm going to get 0.375. Alright, a set of dice are rolled twice. What's the probability of rolling snake eyes on both rolls? Well, snake eyes means a 1 and a 1. So the probability of rolling a 1 and a 1 is 1 out of 36. It said on both rolls, so it has to happen on both rolls. So that's going to be 1 over 36 times 1 over 36, which is 0.00077. Not very good odds. Okay, number 12. All the points will be on number 12. Okay, we did a sample problem like this on the PowerPoint earlier. Okay, a sunglass manufacturer receives frames from 3 manufacturers. Okay. What is the probability that the defective frame was manufactured by company 3? Okay, so let's look at company 3 real quick. 8% and 0.027. Okay. So do you remember what it was? The probability of this was going to be the probability of the one we want, which is going to be number 3, and the probability of the defect. So it's just going to be like this, 0.08. That's the probability that it was produced by them, and then 0.027. That's the probability it was defected, over the sum of all 3 factories. So factory 1 is 0.62 times 0.02 plus 0.30 times 0.013, and don't forget the last one, 0.08 times 0.027. Alright, I'll let you do the handy dandy calculations and do all the math. Alright, there's no reason you can't have this assignment done. You can scroll through this video and look it up and do whatever you need. Now remember, your data points are going to be different based on your simulations or your actual roles. I don't care if you have an Excel spreadsheet that you move the data in, or if you actually tag it on the worksheet that I gave you. But whatever you do, I need you to upload those data points as well. And remember, you need to add your coin toss, your 50 coin tosses, into the forum so everybody can do number E, or part E. All right. Email me if you have any questions. Take care.